This is Dharmendra Reddy MS from CSC AI, Sri Venkateswara College of Engineering. Today, let's discuss about introduction to data warehousing. Data warehousing is a process of collecting and storing data from multiple sources, transforming it into a format that can be analyzed and then making it available to users from reporting and analysis. What is a data warehouse? There are four different types of in warehouse: centralized repository, subject-oriented, non-volatile, and historical data. Centralized repository. The data warehouse is a centralized repository for data that comes from various sources such as transactional systems, web applications, and social media platforms. Subject-oriented. Data in a warehouse is organized by around specific business subjects such as customers, products, or sales rather than by application or functional area. Non-volatile. Data in warehouse is generally not updated in real time. Instead, it is loaded periodically, often on daily or weekly basis. Historical data. Data warehouses typically store historical data which can be used back to track trends and make information decisions. Components of data warehouse. Data source systems. Data source systems are the original sources of the data that will be loaded into the warehouse. This can include transactional systems, web applications, social media platforms, and more. ETL process. The ETL process is responsible for extracting data from the source systems, training it into a format that can be loaded into the warehouse and then loading it into the warehouse. Data warehouse. The data warehouse is the central repository where all the data is stored. It is designed to be highly scalable and performant to support complex queries and analysis. Benefits of data warehousing. Improved decision making. Data warehouses provide a comprehensive view of business data, enabling organizations to make more informed decisions based on accurate and timely information. Enhanced reporting. Data warehouse support the creation of detailed reports and dashboards that can be used to track performance, identify trends, and gain insights into business operations. Increased efficiency. Data warehouses can automate many reporting and analysis tasks, freeing up employees to focus on more strategic activities. Competitive advantage. Organizations that leverage data warehousing can give a competitive advantage by making better decisions faster and by identifying new components for growth and innovation. Dimensional modeling. Fact tables. Fact tables contain the core measurements or facts about a business process. They are typically normalized and linked to dimension tables. Dimension table. Dimension tables contain descriptive attributes that provide context for the facts in the fact table. They are typically denormalized and linked to fact tables. Star schema. A star schema is a simple and efficient dimensional model where the fact table is at the center and dimensional table is radiate out like points on a star. Snowflake schema. A snowflake schema is a more complex dimensional model where dimension tables can be further divided into smaller dimension tables running in a hierarchical structure. Data extraction, transformation, and loading ETL. Extraction. The extraction phase involves retrieving data from the source systems. This may involve query databases, reading files, or accessing web APIs. Transformation. The transformation phase involves cleaning, converting, and aggregating the data to ensure consistency and prepare it for loading into the warehouse. Loading. The loading phase involves inserting the transformed data into the data warehouse. This may involve bulk loading, incremental loading, or a combination of both. Data warehouse architecture, layered and description. Data source systems. The original source of the data will be loaded into the warehouse. ETL process. The process responsible for extracting, transforming, and loading the data into the warehouse. Data warehouse. The central repository where all the data is stored. Metadata layer contains information about the data in the warehouse, such as the data definitions, data relationship, and data quality. Presentation layer provides access to the data for reporting and analysis through tools like dashboards, reports, and analytical information. Maintenance and optimization. Performance tuning. Regularly monitor and optimize the performance of the warehouse by adjusting indexes, partitions, and other configuration settings. Data quality management. Implement process for ensuring data quality, such as the data cleaning, data validation, and data governance. Data refreshing. Schedule regular data refreshes to keep the warehouse up to date with the latest data from the source systems. Scalability and capacity planning. Plan for further growth by scaling the warehouse infrastructure and capacity to accommodate increasing data volumes and user demands.